Okay, so in this question, we want to express in the form r cos theta plus alpha. Now this time is cos, okay, because you notice here we start with cos, right? So whichever one we start with is what needs to go here. So it's going to be cos in this case. And also notice as well that we've got a minus here. That means we need to have a plus in here, right? That's really important, as we see now from the identity from the formula booklet on page 4. So we can express the cos theta plus alpha, okay, by setting theta to be setting a to be theta and b to be alpha. So we put it in here, okay, that's going to be theta, yeah, and that's going to be alpha. So we can have cos a, which is cos theta, and cos b, which would be cos alpha. But then, because we've got a plus here, okay, we choose the plus option here on the top, which corresponds to on the top here, which is actually a minus. So you've got to sort of correspond, you've got to match them up. So you just choose a minus there. And that would be then sine A, sine theta, sine alpha. Now, the reason why these are opposites here is because when you expand this here, it actually then has the opposite in the expansion. And we need this to be minus, don't we, to sort of match up with that. So that's why you get that situation with cos. So when I multiply through by r then, I'll be careful to swap these around, right? So we are cos alpha, cos theta, minus then r sine alpha, sine theta, okay? And that will equal 24 cos theta minus 7 sine theta, all right? Now, we need to match up the sides. So basically, what's in front of the cos theta here is going to equal what's in front of the cos theta there. So r cos alpha will equal to 24. And what's in front of the sine theta there, r sine alpha will equal the 7 here. That's equation 1. That's equation 2. Now, of course, then what you do next is 2 divided by 1. So it'll be r sine alpha divided by r cos alpha, which will be 7 divided by 24. The r's cancel, so you get then your tan alpha, which is equal to 7 over 24. So then you can determine then what alpha is. So alpha will be tan to the minus 1 of 7 over 24. So I get my calculator. And we get out 16.3 degrees, okay, to 1 decimal place. So that's our alpha there. To get r then, remember, to get r, we could sub alpha in, but it doesn't always help us, we don't get it exact. So to get r, we can use Pythagoras, so square these two and add them. And of course, if you square these two and add them, you can factorize out the r squared, sine squared and cos squared then inside, which will become 1. So effectively then you just get r squared will equal then to 24 squared, that squared plus that squared, okay, as we've seen from the previous video, right? And you can just go for it straight like that if you remember. So you know, that squared plus that squared will result in r squared, and then that squared plus that squared, let's work that out. So we get 625, and then that means r is the square root of 625, which comes out exactly as 25, okay? So then you can say, therefore, 24 cos theta minus 7 sine theta equals to 25 cos theta plus alpha, which was 16.3, all right? At the bottom then it says, hence find the range of values of k for which the equation, this equation here, equal to k, has no solution. So, of course, we can replace this 24 minus 7 sine theta with our solution we just had. So we could say, look, 25 cos theta plus 16.3, put that instead of this, and equals to k, right? So therefore, cos theta plus 16.3 will equal to k over 25, yeah? Take the 25 over and divide, all right? Now, if you remember, for cos to have solutions, okay, now the cos graph is between 1 and minus 1, isn't it? So for solutions, cos theta plus 16.3, the cos has got to be less than or equal to 1, or greater than, isn't it? Equal to minus 1, right? It's between minus 1 and 1, the graphs are. So that means k, yeah, has got to be k over 20, you know, we can replace this then with k over 25, yeah? We can say k over 25 has got to be less than or equal to 1 or greater than or equal to minus 1. We can times through by 25, so we'd have k is got to be less than 25, greater than or equal to minus 25. Now that will be 4 solutions, yeah? In other words, k has got to be between minus 25 and 25, 4 solutions. But if we don't want solutions, okay, so for no solutions, if it has no solutions, or if no solutions exist, that means then we've got to have the opposite of this. And the opposite of this means it can't be between minus 25 and 25. Therefore, k has got to be less than minus 25, or k has got to be greater than 25. Okay, so we're outside of that range there for no solutions. Makes sense as well, because if you put more than 25 here, say for instance 30, this would be more than 1, wouldn't it? You can't have cos to be more than 1. So you get that idea there from that.